So now in this session we will be talking about binary number system, because as you know, binary number system actually is the core, right? We have discussed it. Whatever language we are writing it, be it C++, Java, ultimately deep down it has to be converted to binary for system to understand it, right? So which is why it is of prime importance to get an idea around binary number system. So what exactly it is? Binary number system is a base 2 number system, right? So it has two digits, 0 and 1, and we call these two digits as bits, right? So generally any base n number system, if I talk about any base n number system, has digits from 0 to n minus 1, n unique digits, right? So there are total of n unique digits, and those n unique digits will range from 0 to n minus 1. We are aware of decimal number system. I'll relate it to decimal. It's a base 10 number system, right? So we have 0 to 9 as unique digits, total 10 unique digits, and using combination of them we get different numbers. So same is the case here. Binary is a base 2 number system. So whatever number you see in binary will be comprised of zeros and ones only. So this is what we have. Right now, let's talk about a couple of conversions. For example, if I write it like this, this very statement is actually base of many concepts. So if you write something like this, what happens is you get a memory. N takes 4 bytes, so you get a 4-byte memory, right? And 10 is stored. Now I have talked about this already. So 10 directly as a decimal number will not be stored deep down, right? So 10 will be converted to binary, and the binary representation of 10 will be there, and that binary representation will be stored here in 32 bits, because we have 32 bits here, right? So let's see how to convert a normal decimal number to a binary number. So if we have a decimal number, let's say 10, and I want to convert this 10 to binary, how can I do that? So for that, what you can do is write something like this. 2 is the base, 10 is the number. Divide 10 by 2. Whatever quotient you get right here, 5, whatever remainder you get right here, which is 0. 10 completely divides, right? Now divide by 2 again. And whatever quotient you get, which is 2 right here, whatever remainder you get right here. Repeat the process. If you divide 2 by 2, quotient 1, remainder 0. Now if you divide 1 by 2, quotient will be 0 and only 1 will be the remainder. Right? So these are the digits which are of importance for me. So what you can do is now just read them, and read them in top to bottom fashion. So that means this is the most significant bit, 1010. This is the most significant bit, and this is the least significant bit. So this is the most significant bit, and this is the least significant bit, right? So 1010 will be the relevant binary representation. So this is how you can convert any decimal number to binary number. So if you want to do it, just divide by 2, right? And keep collecting all remainders, because you would need them. Eventually all remainders will be read in top to bottom, in bottom to top fashion, right? So the last one being the most important, the most significant bit. This is how you can do it, right? So I hope you get an idea. In fact, you can convert any base decimal number to any base number this way. So let's say if I want to convert 10 to any other base, then all you have to do is write base here, divide by base, quotient here, remainder here, divide by base again, and that's it. So this is a general conversion formula. And other common bases that generally we use, so we have base 2, right, for binary, we have base 10 for decimal, similarly we have base 8 for octal, and base 16 for hexadecimal. So these are other common bases that are there. So if you want to convert from decimal to octal maybe, or decimal to hexadecimal, you can follow this conversion process. This is pretty easy. So I hope this is clear. Now given any decimal number, you can actually convert it to its relevant binary number. Now let's talk about the other way round. So by other way round, I mean I have a binary representation and I want to convert it to its decimal representation. So suppose I have a number like this. This is in binary, brackets in 2, we generally specify base here, and I want to convert it to its decimal number. Now for that, recall about the expanded notation that you must have read about. For example, if I have 1, 2, 3, 4 here, and this is 1234, right? So if I have to write down the expanded notation, that will be 1 into 10 to the power 3 plus 2 into 10 to the power 2 plus 3 into 10 to the power 1 and plus 4 into 10 to the power 0. Right? That means every digit that you are talking about has a place value that it is associated, and we are multiplying that with the place value. This is what you are doing, right? So this is place value 1, this is place value 10, this is 100, and this is 1000. So same is the process that we have to follow here. So talking about 1011, every bit that you see here has a place value. So here base was 10, so place value was in terms of 10. Now base is 2, so place value will be in terms of 2. So 2 to the power 0, 2 to the power 1, 2 to the power 3, 2 to the power 4. And if you want to convert it to decimal, all you have to do is multiply relevant digit by its face value. So 1 into, if I have 1 here, all I have to do is just multiply 1 by 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 plus 1 into 1. 2 to the power 4 is 16. So write 16 here, 0, 4, 2, and 1. This is what we have, right? So the number is 23. So this, what we have written here, actually is the binary representation of 23. And same is the cycle to convert any base number to its relevant or equivalent decimal outcome. So all you have to do is multiply by relevant base. Had it been an octal number, you would have been multiplying here by 8. So you just have to multiply it by its relevant base, and that way you can convert any number, in this case any binary number, to its decimal form, and any decimal number to its relevant binary form. So I hope this is something which you have clarity on. So that means when we are storing 10 here, we are actually getting binary representation of 10, and we are storing that representation over here. Decimal numbers are not stored deep down in memory. Right? So this is what you should have clarity on. As an exercise, just try doing couple of more conversions. Maybe you can try and convert 15 in decimal to what it will be in binary, and then convert it back, that binary, to its relevant decimal value, and see whether you are getting the conversion right or not. Thank you.